This video is on standard form. Standard form is just a way of writing numbers, normally really big numbers or really small numbers, in a shorter way. So you write it as a number between 1 and 10 at the start and then multiply it by 10 to the power of something. If they are big numbers, then they'll have positive powers. If they're small numbers, then they'll have negative powers. So write the following numbers in standard form. So that's 8 million. So it's the same as 8 times 10 to the power of 6, because that means 8 multiplied by 10 6 times. So times by 10 once would get you 80, then another 10, another 10, another 10, another 10, another 10, and you end up back with 8 million again. So there's a number between 1 and 10 times 10 to the power of something. This one, the number that you pick out between 1 and 10 would have to be 7.6. You can't just ignore the 6. And that would be multiplied by 10 cubed, because you're putting the point in there between the 7 and the 6, and you'd need to multiply it by 10 1, 2, 3 times to get it to be 7,600. This one would be 2.54 at the start, and then times 10 to the power of, and you're putting the point between the 2 and the 5, so that would be times 10 to the power of 1, 2, 3, 4, to get it from being 2.54 to being 25,400. So those were all big numbers, so all of the powers were positive powers. These ones, 0.005 is 5, and then you would actually need to be dividing it by 10 3 times to get it to be that small. But instead of dividing by 10 3 times, because that's not the way you write it in standard form, they always want it as a multiplying and then 10 to the power of something. So that's why your power ends up being a -3, because a power of -3 actually means that you're dividing it by 10 3 times. So 5 divided by 10 once would get you 0.5, again would get you 0.05, again would get you 0.005. So whenever it's a small number, instead of dividing by 10, you make the power negative. So this one would be 6.4, not 6.4, it'd be 6.2. Times 10 to the power of, we're putting the point in there, 1, 2, 3, 4, 10 to the power of -4. This one would be 9.12 times 10 to the power of, and we're putting the point in there between the 9 and the 1, 1, 2, 3, 4, 5, 6, so 10 to the power of -6 then. Then these ones are going back the other direction, where you've got a number written in standard form and you want to write it as an ordinary number. So 6 times 10 to the power of 4 would be 6 times 10, 1, 2, 3, 4 times. This one, 7.3, and we're multiplying it by 10 5 times, so the point goes 1, 2, 3, 4, 5. So you would fill in 4 noughts there, and your answer would be a 73 with 4 noughts, or 730,000. 1.28, and we're multiplying it by 10 3 times, so the point goes 1, 2, 3, fill a nought in there, 1,280. This one we're multiplying by 10, but it's a negative amount of times, which means you end up getting a smaller answer, so you're actually dividing. So 7 would have a point after it, then divide by 10, 1, 2, 3 times would move your point there. So you actually get 0.007 for that one. Then 8.6 times by 10 to the power of -4 means move the point back 4 places. So 1, 2, 3, 4, it would go there, and you'd have a 0 point, 3 noughts, and then an 8.6. This one, 5.29 times 10 to the power of -2 means 5.29 and divide it by 10 twice. So go back 1, 2, put a point in there, fill in with noughts, 0.0529, and remember you don't have 2 decimal points in there, that decimal point has moved back 2 places, so 0.0529. Okay, with the standard form then, you need to be able to add, subtract, multiply and divide whenever the numbers are in standard form. So first of all, if you're multiplying and dividing, I would just leave the numbers in standard form, leave them as they are, multiply or divide the whole number bits at the start, and then sort out the powers of 10. So for a question like that, I would do the 2 times the 3 to get 6, and then 10 to the power of 5 times 10 to the power of 4. When you're multiplying, you add the power, so you would get 10 to the power of 9. So then put the whole number back with the tens again, so 6 times 10 to the power of 9. Most of the time in these questions they say for you to give your answer in standard form anyway, so you do want it left like that. So there's no point in you changing it into an ordinary number and then changing it back. Not for multiplying and dividing, because you can just use this method. Then this one, you are dividing, so you do 7 divided by 2, gets you 3.5. And then do the powers of 10, but you're dividing the powers of 10, which means you actually subtract them, so you end up with 10 to the power 4. And then put that together, gets you 3.5 times 10 to the power 4. These two at the bottom here are a wee bit different. So the 4 times the 6 gets you 24, so that 4 times the 6. Then do the 10s times the 10s. So 10 to the power 7 times 10 to the power minus 3. When you're multiplying, you add the powers, but 7 add minus 3, you end up taking away and you get 10 to the power 4. But the reason why this one is a wee bit different, whenever you put those back together, this number at the front is too big. Standard form has a number at the start between 1 and 10, so 24 is too big. So you need to put that down one place, so the 24 becomes 2.4. And then because you're making this one smaller, you go to the power here and make that one bigger to make up for the fact that you're making this one smaller. So 2.4 times 10 to the power 5 would be that answer properly written in standard form. This one then, 3 divided by 4, gets you 3/4, which is 0.75. And then do 10 to the power of minus 6 divided by 10 to the power of 2. Whenever you're dividing, you subtract the powers. So you do minus 6 down another 2. Would be minus 8. And then put those together, get you 0.75 times 10 to the power of minus 8. 0.75 this time is too small, the same way as the 24 was too big, this number is too small. So you need to make it bigger by one place, you need to make it 7.5, and because you're making this first number bigger by one place, you go to your powers and make it smaller by one place. So that would be 10 to the power of minus 9. Because negative 8 down 1 then would get you negative 9. Okay, so that's multiplying or dividing in standard form. Then I would keep the numbers as they are in standard form and then do the calculations, and most of the time they ask you for your answer in standard form anyway. The next few questions then are adding and subtracting numbers in standard form. So this time you have to make them into ordinary numbers first. You can't actually add or subtract numbers that are in standard form because of these powers. They mess the numbers up that you can't just add or subtract them without making them into ordinary numbers first. So 3.2 times 10 to the power 4 would be 3,200, because the 3.2, the point would be there, and you times by 10, 1, 2, 3, 4 times. Then 6.1 times 10 cubed would be 6,100, because the point was in there between the 6 and the 1, times by 10, 1, 2, 3 times. And then you're adding those together, so go 32,000, add on 6,100, gets you 38,100. You might be asked then to write that answer in standard form. If they don't ask you to, then it's okay just to leave that as it is. But in standard form then that would be 3.81 times 10 to the power 4, because you would need to move the point forward 1, 2, 3, 4 to get from this number to this number. The next one then, you need to be careful with negative powers because these will give you decimals to work with. So 5.6 times 10 to the power of minus 1 actually gets you 0.56, because the point was there between the 5 and the 6 and you're going back one place. Then 2 times 10 to the power of minus 2 is 0.02. So the 2 on its own would have a point after it and then back 2 places. And then you're subtracting those, so 0.56 take away 0.02, make sure the points are lined up. 6 take 2, 5 take 0, 0 take 0. So that's fine if you're allowed to leave it like that. If you need to give it in standard form, you would need to make it 5.4 times 10 to the power of minus 1. Okay, so when you're multiplying and dividing, leave it in standard form. Whenever you're adding or subtracting like this, I would take it out of standard form, do the calculation, and then if it asks you, you might need to put it back into standard form at the end. Last question then, sometimes instead of just a simplifying add, subtract, multiply, divide, they give you a real life question. So something like this. The table gives the diameter in meters of planets in the solar system. The diameters are given to an accuracy of 3 significant figures. So there's all of your planets, and then these are the diameters, so that's just the distance across the middle of them. Write the diameter of Mercury as an ordinary number. So Mercury is that one at the top. So as an ordinary number, it would be 4.88, and that means times by 10 6 times. So 1, 2, 3, 4, 5, 6. So you would fill 4 noughts in there. So 488 with 1, 2, 3, 4 noughts. Part B, which planet has the largest diameter? So you would be looking for the one with the biggest power, which are these two here, Jupiter and Saturn. So because they've got the same big power, you then have to compare the numbers in front, and Jupiter is bigger. So the largest one is Jupiter, with 1.43 times 10 to the power of 8. Which planet has the smallest diameter? So look for the smallest power. There's a power of 6, 6, and 6. And then the number at the front, since they've all got a power of 6, there's 4.88, 6.79, and 2.39. So the smallest one there would be the one with the smallest number at the front. So that would be Pluto. So Pluto with 2.39 times 10 to the power of 6. Then part D, what is the difference between the largest and smallest diameters? Give your answer in standard form. So I just had the largest and smallest written down there, so I'm wanting the difference between those diameters, and difference means take away. So you need to write them out as ordinary numbers first. So that would be 143 with 1, 2, 3, 4, 5, 6 noughts. So 1.43, the point was in there, times 10, 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. And this one I'm multiplying by 10 6 times, so 2 would get me to the end, and then another 4 noughts just so that I can line these up properly to the right hand side, and then a 9, a 3 and a 2, and I'm subtracting those. So naught take naught, 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 naught the whole way across there. Naught take 9 you can't go to there, so you have to go right over to the 3, stroke the 3 out and make it a 2, and make that naught into 10. Stroke the 10 out, make it a 9, and then carry the 1 to there. So you've got 10 take away 9 gets you 1, 9 take away 3 gets you 6, 2 take away 2 gets you 0, 4 take away nothing gets you 4, and then the 1. Then they want that answer in standard form. So in standard form that would be 1.4061 with 1, 2, 3. Oh no, sorry, I don't need. When I add the noughts in there at the end, you don't need the noughts at the end. It would just be times 10 to the power of, and the point in there, 1, 2, 3, 4, 6, 7, 8. So times 10 to the power of 8. Just going to check that one on a calculator, plus it will show you what way you would be writing these in. So the biggest one then, Jupiter, was 1.43. So I would be doing 1.43 times 10 to the power of 8. Or you might have the X with the wee box button. Then take away 2.39 times 10 to the power of 6. Yep. So 14061, 14061, and then 4 noughts at the end. Okay, the last question then. Which planet has a diameter that is 10 times that of Venus? So go to Venus. It was 1.21 times 10 to the power of 7. So 10 times bigger means that power would go from a 7 up to an 8. So 1.21 times 10 to the power of 8. And Saturn has that diameter, so Saturn is 10 times the diameter of Venus. Okay, that's the end of that video on standard form.